This is the solution for the mock exam for binomial expansion. First of all, we have expand 2 plus x quantity to the fourth and simplify your result. This should be very easy for you. And let's see, I'm going to start with my technique where I draw 3 boxes for each one of the terms. How many terms are we going to have? Well, you might know just from experience. One of the ways you can figure out how many terms you're going to have is from the order. You might memorize that if you have a fourth order binomial expansion that you're going to have 5 terms. Another way you could do it is you could do Pascal's triangle, and from Pascal's triangle you can figure out that, let's see, 1, 4, 6, 4, 1. The fourth order expansion is going to be this row that has 4 as the second number, and you can see that there are 5 coefficients, so there's going to be 5 terms. Okay? The first term is going to be the Pascal's triangle coefficient, so you could put 1, 4, 6, 4, 1 in the first term. So let's do that. 1, 4, 6, 4, 1. The next box is going to be the A term. Let's use green. So the A term, which is 2, it's going to be 2 to the, and then the power that you're going to take it to is going to be the power of the binomial expansion, 4. So the first time it's going to be 2 to the, and that's not a very good color, is it? It's not very dark. 2 to the 4th. The next one is going to be 4 minus 1, so it's going to be 2 to the 3rd. Next one is going to be 2 to the 2nd. Next one's going to be 2 to the 1st. And the last one's going to be 2 to the 0, which happens to be 1. Right? Now let's do the last last component, last box is going to be the B term of the binomial, which is x, and we're going to take it to the power of 0, so it's going to be x to the 0, which happens to be 1. Then we're going to take x to the 1, x to the 2, x to the 3, x to the 4. Oops. X to the 4. Okay. Now we're going to multiply it out and simplify it a little bit. Okay. So we're going to have 2 to the 4th plus 4 times 2 to the 3rd, which is 8, x plus 6 times 4, x squared, plus 6x cubed, plus 1 times x to the 4th. Okay, so now let's simplify this a little bit. 2 to the 4th is equal to 2 times 2 times 2 times 2, which is 16, plus 4 times 8 is 32x, plus 4 times 6 is 24x squared, plus 6x cubed, no simplifying necessary there, plus x to the 4th. Okay? Alright, so the first part was pretty easy. We could probably do that even on the first day of this unit. Hence, find the term in x squared in 2 plus x to the 4th times 1 plus x squared. So they want to know if you multiply this binomial times this additional binomial, which is a different binomial, what is the coefficient for x squared, or what is the whole term for x squared? And the reason why this is a little bit tricky is because we're going to have to look at a couple different terms in this expansion here. Do you see how they already asked you to expand that? We have the expansion, it's right there. Now we need to figure out what part of this big expansion is going to be multiplied times this to find the x squared terms. Okay, so let's see. Let's say that let's look at the most obvious one, which is this, right? 24x squared. 24x squared does have x squared in it. Now, after we multiply it times 1 plus 1 over x squared, is it still going to have an x squared in it? Let's see. 24x squared times 1 plus 1 over x squared, that's going to give us 24x squared plus 24x squared divided by x squared, which is 24. So yeah, there is a 24x squared term there. Now, is that going to be the only part of this big expansion, 1 multiplied times 1 plus x squared, that's going to give us an x squared term? And the answer is no, because remember that if we multiply like x to the fourth times this binomial, we'll also end up with an x squared term. And the reason why is, here, let's show you here, x to the fourth times 1 plus 1 over x squared, it's going to give us x to the fourth plus x to the fourth over x squared, which is equal to x squared. So now we also have an x squared term here. So there's going to be two parts to this, 24x squared and 1x squared. So if we add those together, it gives us a total of 25x squared. So that is the answer to this. Find the term in x squared as a result of multiplying those two together. Okay, so it just so happens that multiplying the 24x squared times the 2 is going to give us 24x squared. Multiplying the x to the fourth terms times 1 over x squared is going to give us another x squared term. And none of the other terms in the big expansion are going to give us anything with x squared in it. It's always going to be something bigger or something smaller. So that is the answer right there. Okay, let's go to number 2. So this one was 25x squared. Okay, number 2. Consider the expansion of 3x squared minus 1 over x to the 9th. How many terms are in this expansion? Okay, so as we saw in the previous problem, you might memorize that when you have a power of 9 here, that the number of terms is going to be 10. Okay, but if you don't want to memorize that, you could do Pascal's triangle, and you could see that you could see from the first few layers of Pascal triangle that you see how, like, in the power 2 layer there's 3 terms, in the power 3 layer there's 4 terms. So you can detect the pattern just by writing a couple lines of Pascal's triangle. Okay, so the answer is there are 10 terms. Find the constant term in this expansion. And then maybe for this one, since the order is so high, it's 9, maybe you don't want to do Pascal's triangle for this. So what you can do instead of doing my boxes method is you might want to use the general term, which you can find on the formula sheet. The general term on the formula sheet says that you're going to have n chooses r times a to the n minus r times b to the r. And what are a, b, and n in this case? Well, n, of course, is the order, 9. A is going to be 3x squared, and b is going to be negative 1 over x. So let's make those substitutions, and we'll have 9 chooses r. We don't know what r is yet. We'll have 3x squared times, or to the 9 minus r power, and we're going to have b, which is negative 1 over x to the r power. The only thing we know is that it's a constant term, so we can take all the variable parts of this, which are going to be this and this, and we can separate them out. It'll be x squared to the 9 minus r times 1 over x to the r. And I know that all of this multiplied together is going to give me x to the 0 because we know it's a constant term, which has no variable part to it. So let's do this algebra here and figure out what this is going to lead to. So we know that x to the 2 to the 9 minus r is equal to x to the 18 minus 2r, because a power to a power is you can multiply the powers. And then 1 over x to the r is the same thing as saying x to the negative r, right? And now we can equate the exponents. So like on the left side, since we have the same base twice, we can add the exponent. 18 minus 2r minus r equals x to the 0. And now we can now we can really we can equate these. So 18 minus 3r is equal to 0. So 3r is equal to 18, and r is equal to 6. So now we found out that the r value for the term is 6, and then that pretty much gives us the answer, because now we have 9 chooses 6. We have 3x squared to the 9 minus r, which is third. And then we have negative 1 over x to the r, which is the 6th. And then 9 chooses 6. We can calculate with the calculator. Or you could calculate it by hand, but have 9. Actually, I just happen to have it here. 9 chooses 6. Okay, it's 84. But how would you do this from scratch? You would say 9 math, probability, NCR 6. Do you see that? Okay, so that's equal to 84. And remember, 3x squared quantity, the cubed, is actually 3 cubed, and then x to the 6th, right? And then negative 1 over x to the 6th. The negative, when taken to the 6th power, becomes a positive. 1 to the 6th power is also just 1. So basically, in the denominator, we're going to have just x to the 6th, right? And do you see how x to the 6th cancels twice? And so you've really confirmed that it's really a constant term. And then 84 times 27 is 2268. Okay, and last thing, I can show you how to do 9 divided by, or 9 chooses 6. You could do that by hand, because we know that 9 chooses 6 is equal to 9 factorial divided by 6 factorial, and 9 minus 6 factorial. So that's equal to 9 times 8 times 7 divided by 3 times 2 times 1. And 3 cancels with that, we'll have 3 left. We'll have 2 cancels with that, we'll have 4. So that basically is 3 times 4, 12 times 7, which is 84. So that's what we got there, right? Okay, so not so difficult.